Today we're looking at section 5.6, which is called Graphs of Other Trig Functions. Today we are going to be looking specifically at the graph of the cosecant. All right, so remember, cosecant relates to sine. The cosecant is the reciprocal of sine. So it's going to have some of the characteristics as sine, okay? It has a period of 2 pi. But remember, because you are taking the reciprocal, that means that you never want that denominator of sine to be 0, okay? Because remember, cosecant is the same thing as 1 over the sine of x. So I never want 0. So notice how in the picture that dotted curve is the sine graph. Notice that it starts here at 0, 0. Then in a normal graph, it goes up, then back to 0, then goes down, and then it's back to 0. So notice that anytime that it touches the x-axis, for my cosecant graph, I can't have that. So that's when these vertical asymptotes are going to take place. Okay, technically they're in integral multiples of pi. You don't really have to memorize that part as long as you know where your secant graph touches the x-axis or touches that what would technically be 0, depending on then how we shift. Okay, so then notice that as long as we know how to sketch the sine graph, all we're going to do then is put those vertical asymptotes wherever it touches 0, and then in between at the highest and lowest points on the sine graph, we're going to have parabola-looking shapes. Okay, so we use graphs of functions involving the corresponding reciprocals. So like I said, cosecant relates to sine. So if I was asking you to graph y equals 2 times the cosecant of 2x, we first want to think about graphing y equals 2 times the sine of 2x, and then from there we can easily draw in those vertical asymptotes and create those parabola-looking shapes at the maximum and minimum of the graph for sine. Okay, so let's take a look at some examples. We want to graph 2 periods of y equals 3 times the cosecant of x. So remember, that means that I first want to think about the graph y equals 3 times the sine of x. So I want us to identify A, B, and then if there is a C and a D, notice that in this case, there isn't a shift, so we don't really have to worry about C and D. A is the number that's in front of that function, so that's 3. Absolute value of the number in between connected to x, so that B value is 1. So remember, if we know that the amplitude for that sine graph is always going to be the absolute value of A, so that's going to remain 3. Our period is going to be then 2 pi divided by that absolute value of B. So 2 pi divided by 1 gives us a period of 2 pi. So if we think about then those 5 critical points, we want to start with 0, 0. There's not going to be any shifting because once again, there is no C and D. So then remember, we know that since 2 pi is the period, we want to cut it into fourths. So a fourth of 2 pi would be pi over 2. Oops, 2, not 3. And then we want the value for A, which is 3. Then I want half of my period. So half of 2 pi is pi. Then I'm back at 0. Then I want 3/4 of 2 pi, which would be then 3 pi over 2. That is the opposite of A. And then finally, we have that full period of 2 pi, and we're back to 0. Okay, so we want to consistently label our picture. So I'm going to just go up by 1s on the Y. And obviously, I'm going down by 1s. All right, so I'm going to then make every tick mark on the x-axis be going up and down then by pi over 2. All right, so we'll have pi over 2, and then we'll have pi, then we'll have 3 pi over 2, then we'll have 2 pi. So then we'll have 5 pi over 2, 3 pi, 7 pi over 2, 4 pi, and then so on and so forth. We'll have negative pi over 2 on this side, negative pi, negative 3 pi over 2. All right, so I'm going to plot those points for the sine graph. So we'll have 0, 0, pi over 2, we're up at 3, pi, we're at 0, 3 pi over 2, we're down at negative 3, then we're back at 0. That would be one period, okay? Notice that I'm not actually going to be graphing, so I'll do a little dash. I want to see this. So it's just an outline for what the sine is. That's only one period. So now I'm going to have to do a second period. So we'd be going back up to 3 at 5 pi over 2. We're back at 0 when we're at 3 pi. We're down at negative 3 when we're at 7 pi over 2. And then we're back at 0 at 4 pi. Okay, so notice that this is what our picture of the sine graph is. So then now I want the cosecant. So here, I'm going to do it in a different color. So if I see anywhere that my sine graph is at 0, so in the middle of the highest and the lowest point, that's where a vertical asymptote is. So at 0, 0, which is my y-axis, I've got a vertical asymptote. At pi, I'm going to have a vertical asymptote. At 2 pi, I'm going to have a vertical asymptote. Same thing then with 3 pi and at 4 pi. Okay, so then now it leaves me with the highest and the lowest points. So that's where we're going to have our parabola-looking shape. Make sure that it is touching that highest or lowest point, but make sure it does not go or touch through those vertical asymptotes that you just drew. Okay, so notice that 2 different periods means that I need to see 4 of these parabola-looking shapes, 2 of them going up and 2 of them going down. And that is our picture and our graph of this y equals 3 times the cosecant of x. Okay, let's take a look at this one. We want to graph 2 periods of y equals the cosecant of 2x minus pi over 2 plus 1. So remember, we're going to start off by thinking of it as y equals the sine of 2x minus pi over 2 plus 1. All right, so to figure out that information for sine, we want to identify A, B, C, and D. Remember, A is in front of our function, so 1. B is connected to x, so 2. We want to take the opposite sign for C, so that would be positive pi over 2. We keep the sign for D, which is 1. All right, so then if we're thinking about our amplitude, we're going to have the absolute value of 1, so 1. If I'm thinking about the period, we want to think about 2 pi and divide it by b, which is 2. So that means our period is pi. We now are going to have a phase shift. Remember, your phase shift is always c divided by b. So our value for c is pi over 2. Our value for b is 2. So think of that as pi over 2 being multiplied by the reciprocal, so 1/2. So that means pi over 4 is that phase shift. And then we are going to have a vertical shift at positive 1. All right, so we want to do our 5 critical points. So we'll start off with just doing the A and B values, and then we'll transition into the shifts for the phase shift and the vertical shift. So we'll start at 0, 0 when we're talking sine. Then I want to take a fourth of the period. So if pi is my period, pi over 4 is a fourth. And then I want the value for a, which is 1. Then I want to take half of the period, so pi over 2. Then I'm back at 0. Then I want 3/4 of the period, so 3 pi over 4. Then I want the opposite of a, so -1. And then I want the full period, which is pi, and I'm back at 0. But those are not what we're going to want to plot, because we are going to now include the phase shift and the vertical shift. So phase shift is moving left and right. It's a positive pi over 4, so that's what all the x values are being added on. Vertical shift moves up and down, so that's the y's. We're going to add 1. So 0, 0, I'm adding pi over 4 and 1. So the ordered pair we want to plot is pi over 4, 1. Next ordered pair, when I add pi over 4 and pi over 4, it's 2 pi over 4, which reduces to pi over 2. 1 plus 1 is 2. Pi over 2 plus pi over 4, think of it then as we had to get those common denominators. We just said pi over 2 is the same thing as 2 pi over 4. Add another pi over 4, we're at 3 pi over 4. 0 plus 1 is 1. 3 pi over 4 plus pi over 4 is 4 pi over 4, so pi. -1 plus 1 is 0. Think of pi as 4 pi over 4. Add a pi over 4, and you've got 5 pi over 4. And 0 plus 1 is 1. Okay, so that means that these are the ordered pairs of the sine graph that we want to mimic, but not quite graph, because remember now we're doing cosecant, not sine. All right, but I'm going to start labeling my x and y axis first before I even try to sketch that. So I'm going to go up and down by 1s on the y. As far as then my values for the x, I'm going to go up and down by pi over 4. Okay, so we start at pi over 4, then 2 pi over 4. Then we have 3 pi over 4, 4 pi over 4, so pi. 5 pi over 4, 6 pi over 4, which is 3 pi over 2, 7 pi over 4, 8 pi over 4 is 2 pi, 9 pi over 4, 10 pi over 4, 11 pi over 4, and so on and so forth. I could go the negative route as well. So negative pi over 4, and then this would be -3 pi over 4 over there. Okay, so now that I have my x and y labeled very clearly, can plot my points. So pi over 4, 1, pi over 2, 2, 3 pi over 4, 1, pi is at 0, 5 pi over 4, we're at 1. Okay, so that means that this is one period of the sine graph. But remember, I want to graph 2 periods of cosecant. So that means that then we're back up to +2, then we're at 1, then we're at 0, and then we're at 1 again. And there is my next period. Okay, so notice that. Remember, the highest and the lowest points are where your parabola-looking shapes are. So that means for us in the middle, because we shifted up 1, anywhere that we're at 1, that is going to be the vertical asymptotes. So at pi over 4, I want a vertical asymptote. At 3 pi over 4. At 5 pi over 4. 7 pi over 4. 9 pi over 4, and anytime else. Okay, so then now notice that we'll have our, do it way better than that, please. Parabola-looking shapes at the highest and the lowest point on our sine graph. All right, and they should be touching those points. And there is my 2 periods of the cosecant graph. All right, so that's us graphing cosecant and different variations of it.